Hello viewers, welcome to Vidyapeetham. I am Nageshwari, working as an assistant professor in RMK College of Engineering and Technology. So, in previous lecture, we have seen about the introduction of 4-variable K-math, its mean-term representations along with the its by variables, that is A, B and B, C, how we should represent the mean terms in each cells, and as well as some double grouping examples. In this lecture, we are going to see about quad group combinations and octet group combination with some examples. Now, the next one, so we will recollect it. So this is called as the 4-variable representation. So in 4-variable representation and along with its minterm representation. Now let us see few examples of grouping. So here we can make it as a 1 and here 1 and here 1 and here 1. So this combination also we can make it as a quad grouping, that is, so this is one grouping, this is a grouping, and this is 1 and this is 1. So likewise we can make a adjacent pair as a quad grouping. Okay, so this is one possible combination. And the another example we can see, that is, so 0 like this. So if you make a grouping as like this, so now this is called as the octet possible combination. This is called as the octet possible combination. Now, so this one is also called as the octet possible combination. Now if you see like this, so this is also called as the octet possible combination, that too in a adjacent side. Okay. Now if you see, this is also one octet possible combination. This one and as well as this one. This is also we can make it as a octet possible combination. So likewise we can form a group. Okay. Now the next one, we will see some examples, that is example number 1. So we will see the example and how to write the expression. Okay, how to write the Boolean expression with this grouping. So the first example, let us say, so f is equal to, so summation of, so 4, 5, 6, 9, 13 and 14. So now how to make a grouping, that is, so here 4 and here 5, 6, 9, 13, 14. So can we write the grouping first? Can we make a grouping first? Yes, that is, so this is one possible grouping, clear, and this is one possible grouping, right? Okay, and which one we can make, and this one is one possible grouping, that's it. Okay, so this is what possible, this is the first possible grouping, and this is the second possible grouping, and this one is the third possible grouping. Okay, so therefore we'll write the expression for this grouping. That means in the first grouping, that is AB is not changing, so therefore A bar B, and in this combination, so C is not changing, so therefore C bar. Similarly, if you see the second grouping, so here, so this is first grouping, here we can say this is second grouping and this is third grouping. Okay, right? Okay, in the second grouping, so AB is changing, that is, sorry, A is changing whereas B is not changing, so therefore B. Okay, here CD is not changing, so therefore CD bar. So plus, and in this grouping, so here again A is not changing, so therefore A, and CD is changing, not changing, so therefore C bar D. So this is how we have to write the expression for the given example. Okay. So now let us see another example, that is, so let us see this example, that is, so summation of f is equal to summation of 4, 5, 6, 7, 9, 13, 14, 15. Okay, that means 4, 5, 6, 7, 9, 13, 14, 15. Okay. Now, if you see this, so this one we can make it as a one possible grouping, right? Okay. So this one we can make it as a one possible grouping. Now next one is which one? So these two is left out. So therefore we have to think any other combination is possible or not. No, there is no other possible combination. So therefore we can make it as this is as a separate group. So therefore the equations are, so this is our first combination, right? First grouping, right? So therefore here AB is not changing. So therefore A bar B plus, for this here for the second group the B is not changing. So therefore B, and also so here the C is not changing. So therefore C plus, so in this group of combination, so we have what? So A is not changing. So therefore A and here we have C bar D. C bar D. Okay. So this is the Boolean expression for the given problem. Right. Alright. Now we will see another example, that is f is equal to summation of 0, 1, 5, 6, 7, 8, 9, 13, 15. So 0, 1, 5, 6, 7, 8, 9, 13 and 15. Yes. So how to make a grouping? So we have to think once or twice, so before grouping, right? Okay. So which one we can make it as a group? That is, so immediately if you see this 4 1 means, so we can group this as a first, right? Okay. But we have to think once or twice before grouping. Okay. That means, so this combination and this combination leads to one grouping, right? Clear? So this is one grouping, right? Okay. Now the next one. So the next one is, this 4 is one grouping. We can make this 4 as one grouping, right? Okay. So this is one possible combination. Clear? And this one is lefting out. So therefore this one we can make it as a one group, such that all the ones are paired each other, right? Okay. So this is how we have to group. We have to think once or twice before grouping, and then we have to form a group. Now in this, so next how to write the expression. So if you look at the first grouping, if you look at the first adjacent grouping here, so A variable is changing but B is not changing, so therefore B bar. And if you see here, so the C is not changing, so therefore C bar. And in second grouping again, here B is not changing, so therefore B, and C is not changing, therefore C. So plus, and here in this third grouping, so therefore here, so AB is not changing, So therefore A bar, B, and here also C is not changing in the third group. So therefore C. Okay. So this is how we have to write the expression for this problem. Let us see some more examples in the next video. Thank you.